So we will look at the ellipse today, and now there are a lot of words here. Let's not look at the words, okay? Let's focus on something right here. Now, I want to focus on these two equations, okay? These two equations, well, they're important. But the first thing that I want to highlight here is to ask a very simple question. That is, can you see anything the same when compared to the circle equation? Okay, can you spot out anything the same compared to the circle equation? Okay, we'll say, well, everybody should see that, you see the parentheses, right? Square, hey, the x minus h, same thing. The y minus k, same thing. So you can still tell the center easily, just like the center, just like the circle equation. The difference, oh, and also the what's the same? The adding. That's still the same. The difference is that you get a fraction. There's something called a squared. There's something called b squared. It's not equal to r squared anymore. It's equal to 1. Well, why is it not? Why is it not r? Well, because it's called an ellipse. The distance from center to the edge, it's not a constant. It's going to change. So that's why you can use that as an explanation of the difference. Okay, so we got a fraction. We got two fractions here. It's equal to 1. And if you look at these two equations, you also recognize something different, which is that yeah, that's an a squared for the top equation right underneath the x. But for this second equation, the a squared is, hey, it's underneath the y. Well, why is that a difference? Well, this is how we can make our memory work for us. If the a is placed underneath the x, oh, by the way, a in this case is a bigger number because a is the distance from the center to the edge of the endpoint on the long major axis. Okay. Now, do not just think about, oh, it's the major axis. Make sure that you have a picture. You can label it, and you can say to yourself that it is the distance from the center to the end of the major axis. That's the A, whether it is horizontal or vertical. Okay, that's the A. And if A, the big number square, it's placed underneath the X, then you know it's horizontal. If the A, the big number square, it's placed underneath the Y, then you know it is vertical. So it's something really easy to spot out, and you will just use that piece of information to tell the feature. So again, it's all about how readily you are to tell some features. So A, again, is the distance from the center to the end of the major axis. So if that's A, well, what would you say about the length of the entire major axis? Well, 2A, right? So that's why up there, up top, the major axis, it says the length is 2A. I think it's common sense if you know what A is. So that's A. That's a long major axis. Hey, guess what we use for B? B would be used to label the shorter minor axis. From the center to the end of the minor axis. So we have A, we have B, okay? And then we have A, we have B, well, guess what? We have C. And what is C? Let's go ahead and label this. C, you can put it right here, okay? Well, the distance from the center to something called focus. Okay, this is called focus. That's called C. Okay, so we have A, we have B, and we have C. Okay, let me label the A, B, and C for the other diagram as well. So this is B, and then you have you can make a focus right here, and this distance would be C. Okay. So earlier today, I asked student that what is C, and they just say focus, and I said that's not helpful. It is the distance from the center to the focus. Okay. All right. So you have A, you have B, and you have C. And now, what is the relationship between A, B, and C? Now, there's a little equation right here on the left. It is C is equal to square root of A squared minus B squared. All right. So they're the same, whether it's vertical or horizontal. But I want to write down an alternative equation, and that is C squared is equal to A squared minus B squared. And you probably may think like, wait. A squared, B squared, C squared. Wait, hold on. It looks like something, but is that something? Is it that something? Is it that? But that's A squared plus B. Wait, hold on. So you might be thinking about Pythagorean theorem, and I would say let's not worry about it. Okay, let's worry about the relationship between A, B, and C. Are you able to label? And for one simple fact, based on this diagram, A, B, and C, which one's the longest? We say A, right? A is the longest. So to relate A, B, and C, well, it has to be a subtraction because C is shorter than A. It has to be a subtraction. If it turns to be an addition, then C will be longer than A and B, right? So it can't be an addition. It has to be a subtraction. So let's not relate this to triangle. Let's not worry about this. Like, is it related to Pythagorean theorem? No, let's not worry about this. Okay, for ellipses, C squared is equal to A squared minus B squared. Okay. Now, so you can see an ellipse is just a stretched circle, right? And so we have something called eccentricity right here, eccentricity, to describe how round or how stretched it is. So the way we calculate eccentricity is C over A. And if E is equal to 0, well, 0 is pretty round, right? So if E is equal to 0, then it is a circle. So I think the circle, the 0 itself gives you the hint of what it is. If E is equal to 0, it's a circle. Okay, that's pretty straightforward. The other thing that's kind of important is this one, lattice rectum. We will mention about the length, and there's a little equation that we use. Length is 2b squared over a. So got to have that memorized. What is the lattice rectum? Let me go ahead and draw it here. The lattice rectum is a line that it's drawn that's perpendicular to or through the focus, and it's drawn through the focus and perpendicular to the major axis. Okay, so we will talk a lot more about lattice rectum later on when we talk about parabolas, but here we just mentioned about the length. Okay, so that's pretty much the essence of what an ellipse is. And what I would say is because of the different orientations, whenever you have the slightest hint or you have some idea of where it orients, then go straight ahead and draw a little quick sketch of the ellipse. If it's vertical, draw a quick sketch of a vertical ellipse. If it's a horizontal, draw a quick horizontal ellipse.